Hello there, this is Miss Nakayama, and today's lesson is 5.5a, Trigonometric Equations Part 1. So I've taken this section and divided over 2 days because there are lots of different kinds of trigonometric equations. So I tried to divide it between easy and hard, and we're tackling the easy ones today. There are so many different types, y'all. I'm trying to do one of each type, but I can't possibly solve every equation for you. So do your best to get the summary and get the ideas. All right, so the types of problems we're going to be doing here. First off, we're going to solve equations where we have to find all the solutions. Then we're going to find solutions where we have multiple angles involved. We're going to solve some that are quadratic in form. And then we're going to also use some factoring, simple factoring. Okay, so just to make sure you know, a trigonometric equation is any equation that contains a trigonometric expression. Solutions are any values that satisfy that equation. And whenever you're dealing with multiple angles, it's very important to remember the period of the function. And you'll see as we go through and do it. So, two main steps. Isolate the trig function and then solve for the variable. So, I got 6 examples to go through. Again, trying to do my best to show you one of each type. All right, so first off, the one we're going to do is finding all solutions of a trigonometric equation, which technically you should be doing every time unless you see something like this. So if it says only solve it between 0 and 2 pi, that means only one time around the unit circle. Otherwise, you have to go find all of the solutions. And to find all of those solutions, then how we're going to do that is we're going to add back the period times n, and you'll see as we go through. So first off, 5 times the sine of x equals 3 sine x plus the square root of 3. So this is a trig function, and that is the same trig function, so it's as if it's x, okay? So if I had 5x equals 3x plus the square root of 3, and I had to solve for x, I would combine. I would have to bring this over here. So 5 sines minus 3 sines, when you subtract, of course, gives you 2 sine x equal to the square root of 3. Then again, I'm trying to isolate the trig function, so I'm going to divide by 2, and sine of x equals the square root of 3 over 2. So that tells me that x equals, I'm looking at my unit circle, pi over 3 or 2 pi over 3 because it's in the first and the second quadrant, the green, if you have the color-coded one. Okay, now we have to remember, excuse me, this all solutions. And so as I said, you're going to add back the period times n. So what is the period of my sine function? It is 2 pi and then times n. And so I have x equals pi over 3 plus 2 pi n, and then 2 pi over 3 plus 2 pi n. And that's what you do. All right. Most of the other ones we're going to concentrate are not going to be finding all. We're going to be finding them between 0 and 2 pi. So this example is concentrating on solving an equation with a multiple angle. Now, how do I know they're multiple angles? Because there is a 4 in front of my x. Okay, that's different. The last one just said sine of x. Okay, now, first and foremost, you cannot do anything to this thing I've highlighted until you get rid of the trig function. So don't go thinking you can divide by 4. You'll miss everything. So once you look at this, you say the cosine of some angle is equal to the square root of 2 over 2. So from my unit circle, that means that angle, which in this case is 4x, that angle equals pi over 4 and 7 pi over 4. That's where the cosine is positive, first and fourth quadrant. We're on the purple line. Okay, so I have to now solve for x. So I'm dividing by 4. So that's going to give me x equal to pi over 16 and 7 pi over 16. Now, this is where we get into, it says 4x. So if I have 2 answers to start with, I really have 2 times 4. I got to have 8 answers. How do I find the easiest way, y'all? This is so much easier than you do it in math lab. So I hope you're paying attention, but if not, read the example and I can tell, but it's not a problem. This is easier than that, okay? But what is the period of my cosine function? The period of my cosine function is 2 pi over b, and b is 4. So when I reduce that, that's pi over 2. So on your calculator, you're going to add pi over 2 to pi over 16 4 times, and you'll get 3 times to get 3 more answers, and then you're going to add it to 7 pi over 16 to get 3 times to get 3 more answers. You'll have a total of 8. Or I'm going to do it by hand, okay, in case you don't have a calculator that does all that work for you. Sometimes it takes longer. Pi over 2 is equal to 8 pi over 16, okay? So I'm going to add 8 to my numerator each time. And I just keep them in order. You don't have to, but I'm going to do the first one. So 1 pi plus 8 pi is 9 pi over 16. 7 pi plus 8 pi is 15 pi over 16. 9 pi plus 8 pi is 17 pi over 16. 15 pi plus 8 pi is 23 pi over 16. 17 pi plus 8 pi is 25 pi over 16. And 23 pi plus 8 pi over 16 is 31 pi over 16. And if you keep going, 25 pi plus 8 pi is 30, come on. 25 pi plus 8 pi is 33 pi over 16. But I hope you realize that 2 pi is 32 pi over 16, because if I just multiply by 2. So it means this one is bigger than 2 pi, and it's not part of my answer. Okay? All of these extra ones, all I did, y'all, was add back the period. Find the period and add it back. Again, a lot simpler than what you see in MyLab Math. So I hope you write that down. Remember. All right, let's do another one. All right, another multiple angle. This time we're dealing with the tangent of 2x. So you think to yourself, where is the tangent equal to the square root of 3? And the tangent is the square root of 3 up top on the green line. So that means this angle of 2x equals pi over 3 or 4 pi over 3, because tangent is in opposite quadrants where it has the same sign. Okay, I'm going to divide by that 2 and get pi over 6, and 4 pi over 3 divided by 2 is 2 pi over 3. And now I'm going to add back my period to get the other ones. Period of the tangent function is pi over b, not 2 pi over b, because remember we're in opposite quadrants. So I'm going to write that in terms of sixths. Okay, again, do it on your calculator if you want to. That's equal to 3 pi over 6. So if I add 1 plus 3 is 4 pi over 6. Well, that's what this guy is right here. So then 4 pi over 6 plus 4 pi over 6 plus, actually I just added it here. 4 pi over 6 plus 3 pi over 6 is 7 pi over 6. And 7 pi over 6 plus 3 pi over 6 is 10 pi over 6, which reduces to 5 pi over 3. And I have my 4 answers. I started with 2. 2 times 2 is 4. So that's all I got for my answers. Again, I added back the period to get those extra angles. So multiple angles means I'm going to have extra answers. All right, example 4. Solve a trigonometric equation in quadratic form. What makes it quadratic? That thing right there. Okay, now I still only have one trig function, so I'm going to isolate this trig function. And so I'm going to add 3. 4 cosine squared x equals 3. I'm going to divide by 4. So cosine squared x equals 3/4. And then I'm going to take the square root of both sides. And when you take the square root, y'all, you've got to remember to plus or minus is part of the problem. Square root of 3 is 3. Square root of 3 is the square root of 3. Square root of 4 is 2. So that becomes the square root of 3 over 2. Now, a simple way, y'all, when you're trying to figure this out, okay, where is the cosine square root of 3 over 2? That is on the red line, x equal to pi over 6, okay? But if you have plus or minus, then you're going to need the 1 in every quadrant. So that's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Again, have your unit circle handy if you don't know these already. Okay. Number 5, another quadratic in form, but this one is different because I have more than one trig function in it. Okay, so whenever we have more than one x, if I have an x squared and an x, then I have to bring everything to one side and set it equal to 0. So that is 2 sine squared x minus 3 sine x plus 1 equals 0. And then I'm going to have to factor it. The only way to factor 2 sine squared is 2 sine x times sine x. The only way to factor 1 is 1 and 1, and they're both negative because that middle term is negative. So then I set each factor equal to 0. 2 sine x minus 1 equals 0. I'm going to add 1, and then I'm going to divide by 2. Divide by 2. Here on the other side, sine of x equals 1. Sine of x minus 1 equals 0. So I'm going to add 1. Now, if you had trouble getting there, there is another way of doing it. We did it when we had logs and exponents. And that is, we let u, we call this u substitution, and we let u equal the sine of x, which makes u squared, if I square both sides, equals sine squared x. So this equation would be 2u squared plus 1 equals 3u. Still have to bring it all on one side, set it equal to 0, factor it, set each factor equal to 0, and then solve each factor. But hopefully that should let you know that original problem doesn't have a u in it, so you're not done. So if you remember what u is equal to, then the u equals 1/2 brings us to that equation, and u equals 1 brings us to that equation. So what are my answers? Where is the sine equal to 1/2? Well, the sine is 1/2 at pi over 6, at 5 pi over 6. I don't know what happened there. At 5 pi over 6, and sine of x is equal to 1 up top at pi over 2. So those are my answers. All right, last problem, number 6. This time we are going to have to factor. Okay, so this is not a quadratic factoring. It is, hope you can see that, a different type. Sine of x tangent x equals sine of x. I have more than one trig function in here, and I have more than one type. So I'm going to have to bring it to one side to factor it. If you think it's okay to divide both sides by sine, you will lose a factor, and the answer will not be correct. So you need to bring it all to one side. Sine x tan x minus sine x equals 0. Then I have a common factor of the sine, so I'm going to factor it out. This should be easy for you after doing those identities because we had a lot of factoring like this. So I'm left with tangent of x minus 1. Remember, started with 2 terms, got to have 2 terms in that parentheses. Set each factor equal to 0. Tan x minus 1 equals 0. Add 1 to both sides. And so, where is the sine 0? Sine is 0 at 0 and at pi. And where's the tangent 1? At pi over 4 and 5 pi over 4. So, those are my answers. Y'all, multiple angles give people trouble, so write down something to help you remember that. But thank you so much for watching, and y'all have a great day.